In this question, we're told that ABCD is a quadrilateral. We're told that length AB is equal to length CD, and that angle ABC is equal to angle BCD. Now we need to prove that the line AC is equal to the line BD. And we can start by drawing in these lines. So AC would be here, and BD would be here. Now we need to prove that these two lines are equal. So what we need to realize is that this question is asking us about congruency. And so we can start by defining what congruency is. Two triangles which are congruent are identical in size and shape. Now that we've defined what congruency means, we can go ahead and outline the two triangles that we'll need in this question. So we've already drawn the lines AC and BD onto our diagram. The first triangle that we'll need is triangle BCD. And now the next triangle is triangle ABC. Now we need to take a look at how we can prove that two triangles are congruent, and there are 5 main ways we can do this. We have 5 different abbreviations that we need to know about. We have SSS, SAS, ASA, AAS, and finally we have RHS. So what do these mean? Well, SSS stands for side, 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 which means two triangles are congruent if they have 3 equal side lengths. SAS stands for side, angle, side, which means two triangles are congruent if they have 2 equal side lengths and the angle in between them is also equal. Then we have ASA, which means angle, side, angle, which means two triangles are congruent if they share 2 of the same angles and the side in between them is also equal in length. Then we have AAS, which stands for angle, angle, side, which means two triangles are congruent if they share 2 of the same angles and the side that's not in between them is also equal in length. And finally, we have RHS, which stands for right angle, hypotenuse, side, which means two triangles are congruent if they share a right angle, the same hypotenuse, and then the same other side length. So now looking at the triangles in our diagram, we need to find out which rule applies. So we can see that both triangles share the length BC. Well, we're told that angle ABC equals angle BCD. In triangle ABC, angle ABC is in the middle. And in triangle BCD, angle BCD is also in the middle. Now, since these angles are equal, we can say that both triangles have the same angle. So far, we've seen that both triangles share one length, and both triangles share one angle. So we can highlight these shared properties in yellow, just like we've done with the angle. So we'll highlight line BC because we discussed that both triangles share this side. And now we're also told in the question that line AB is equal to line CD. So in triangle ABC, AB is a side. In triangle BCD, line CD is also a side. Since they're equal, we can say that both triangles share an equal length. So we'll highlight CD over here and AB over here. So now we can see that both triangles share the line BC. We can say that they also share the side length AB and CD because they're the same length. And then they also share the angle ABC and BCD since they are equal. So the triangles that we're looking at share 2 sides and an angle in between them. We can see that on line AB and triangle ABC, we have line AB, angle ABC, and line BC. And triangle BCD, we have line BC, angle BCD, and line CD. So looking at the laws below, we can see that our triangle follows the rules side, angle, side. And so we can say that triangle ABC and triangle BCD are congruent. Now to prove that AC equals BD, well, we discussed that two triangles that are congruent are identical in size and shape. And so if triangle ABC and triangle BCD are congruent, that means for both triangles, that last side that we haven't looked at, must be the same. And the last side, well, in triangle ABC, that's line AC, and triangle BCD, that's line BD. And so we can now say that line AC is equal to line BD. We'll start by writing down the first link between the two triangles, and we'll say that angle ABC is equal to angle BCD. The second link is that line AB is equal to line CD. Then we'll write down the third link, and that hasn't been given to us in the question, so we need to describe why this is the third link. So we can say that line BC is equal to line BC, and that's the line that's common between both triangles. And then finally, we can prove that AC equals BD by saying that triangle ABC is congruent to triangle DCB because they share two sides and the angle in between them is also equal. And so this is the reason SAS, as we discussed before. Therefore, we can say that line AC is equal to line BD. This question is worth 4 marks. And so the 4 statements that we wrote down will be where those 4 marks are allocated. We'll get the first mark for stating the first link, that angle ABC and angle BCD are equal. The second mark will be for stating the second link between the triangles, that line AB is equal to line CD. The third mark is for stating the third link, which is that they share a common side, which is line BC. And finally, that fourth mark is for that conclusive statement, saying that triangle ABC and triangle BCD are congruent because they share SAS, and therefore line AC is equal to line BD.